thing I want to start with is area of polygons. Polygons is a big thing you're going to see in 6th grade math. We're going to use regular polygons finding the area of regular polygons like our squares, our triangles, our trapezoids, and our parallelograms. We're going to use these areas to find areas of irregular shapes, like a funky shape that you would see. Okay. So just to get us started, first off, we are going to make this foldable, okay? This is what it will look like in the end, where it does open up and then open up again, okay? Unfortunately, you are not working with a white piece of paper. You are working with a yellow piece of paper, so make sure you have a yellow piece of paper, okay? All right, before we get started on actually folding it, I want to write our objective for today. So our objective is I can find the area of polygons and use them to find area of irregular shapes. So make sure you have that written down in your notebook as our objective for today. All right, so making this wonderful foldable. All right, you have your yellow piece of paper, okay? Notice there's a bunch of writing on it, and some of it's a little upside down. That's okay. So first off, we're going to fold our paper hamburger style. Fold our paper hamburger style. All right, we folded our paper hamburger style. Now, we're going to flip it over. And again, folded hamburger style one more time. So hamburger is what we're doing. Hamburger, and you should come up with a yellow area of polygons foldable. Again, when you open it up, you've got some formulas, and if you open it up one more time, we've got some examples and another formula. Yes, I realize some of our examples got into the fold, and that's okay. We'll make it work. All right, so first off, when we're looking at the outside here, we've got some regular polygons here. We've got a triangle, a trapezoid, parallelogram, and a more like a rectangle. So we're going to go over the formulas for finding area of those. Okay. All right, first off, when we are finding area, we are finding the inside, what's on the inside of a 2D shape. So these are just 2D shapes. They are not 3D shapes. Okay, this is a 3D shape. It's a cube. Those are 3D shapes. 2D shapes are just plain old shapes you see in your everyday life. Okay, so first off with a square. Okay, we're going to draw a square because in geometry, why not draw our shapes? Okay, I understand my square might not be perfect. Please don't judge me on my drawing skills. All right, when we're talking about the area of a square, we're talking about the length times the width. You're always multiplying some side times another side to find the total on the inside, okay? Because that's what we want to find. We want to find all of that on the inside. Okay? Let's say we have 5 feet by 5 feet. What's special about a square is that all of the sides are equal length. So if you know if one side's 5, then all the other ones are going to be 5 as well, okay? Length is usually on the bottom. Width is usually on the side. Length is usually the longer one, width is usually the shorter one. It does not matter because with the commutative property of multiplication, order does not matter. Okay, so in this case, our length is going to be 5, and we're going to multiply that. Our width is also 5. 5 times 5 is going to be 25. And because we are multiplying feet times feet, we're going to have feet squared. This is our repeated multiplication, which we can use with exponents, so it's going to be feet squared. That's our area. For rectangle is pretty self-explanatory as well. Okay, what's special about a rectangle is that opposite sides are parallel, but they're also equal. So if you know one side is one length, the other side is also that same length. In this case, let's say that the bottom one is 7 inches and the side one is 3 inches. I know if the bottom one's 7, the top one's also going to be 7. Same with the opposite sides. This side's 3, the other side's also going to be 3. Okay. And our length, we're still going to multiply length times the width, same area as the square. We're going to have 7 times 3. 7 times 3 is going to get us 21. And because we are multiplying inch times inch, it's going to be inches squared. And always circle your answer. All right, a parallelogram. Okay, you may have heard of a parallelogram. If not, you're going to find out now. Okay, a parallelogram is really, in short sight, it is just a tilted square or a tilted rectangle. That's basically all it is. Okay. What you know about a parallelogram is that opposite sides are parallel, meaning the opposite sides will never run into each other. Okay. Now, because our sides are tilted, to find the height or the height of this shape is going to be a little bit tricky, okay? When we look at our area, this formula is a little bit different. It's base times the height, B times H. This is the base times the height. So you'll see length times width, but for some shapes we want the base times the height because bases are our bottom and tops, and our height determines how tall our shape is. So we are using base times height, okay? All right, to find the base is always the bottom, okay? In this case, for example, we're going to put 8 centimeters. For our height, to find the height, you're going to find it one of two ways. A, our height has to make a 90-degree angle with the base, okay? So you'll see sometimes little dashed lines like this, and you'll see a little square. That's our 90-degree angle. They'll tell you that that also demonstrates height. You also see it on the inside as well. You'll see height like that as well. Either way, it took, there's a line from the top to the bottom, and the height makes a 90-degree angle with the base. So as long as your height makes a 90-degree angle with one of the bases, then that is your height, okay? In this case, we're going to make it as 5 centimeters. So again, base is just the base of the parallelogram. This extended part is not the base, okay? So remember, that's not the base, it's just the base of the actual shape, okay? We do use these lines for the height because remember, it has to make a 90-degree angle with one of the bases, okay? Now, this one's always pretty straightforward. We got our base as 8. We're going to multiply it times our height, which is 5. 8 times 5 is 40, and because we're doing centimeters times centimeters, it's going to be centimeters squared. All right. Our triangle, okay? You'll see different kinds of triangles. You'll see a right triangle, meaning it has a right triangle, or sorry, it makes a right angle at where two of the bases meet, okay? Or you'll also see triangles like this. And again, same with our parallelogram, okay? There is no right angle here, so they make a height from the top to the base where there is a 90-degree angle, and you'll see the height like that as well. All right. But in this case, for our triangle, okay, notice that triangles are funky shaped, okay? But you also notice that if I put two triangles together, here, what shape do they make? They actually make a square, which is actually really nice. So if we take our area of a square, which is length times width, okay, and I cut it in half because a triangle is half of a square, that's where I get my formula of 1/2 times base times height. Okay, so I take my base, I multiply it times the height, which is the same as your length times width, but now I want to cut it in half because a triangle is half of a square. Okay, so in this case, I gave the example of our base is going to be 8 feet and our height's going to be 9 feet. All right, so we have 1/2. I'm going to plug in 1/2. Our base is going to be 8 feet multiplied by 9, which is our height. And remember, with our order of operations, our PEMDAS, we want to do what's in parentheses first, okay? 8 times 9 is going to be 72. And I'm going to bring that half down. 1/2 times 72, okay? If you just divide 72 by 2, you actually get 36. And when we do feet times feet, that's going to be feet squared. Triangles, the only hardest part is remembering to multiply it by half or divide by 2. That's the hardest part in finding the area of a triangle. All right, opening up our foldable. We're going to work with a trapezoid, okay? A trapezoid you will see like this, where one base is longer or shorter than the other base, okay? If you were to deconstruct this, okay, and making our heights, you actually notice this is made up of a rectangle and triangles. Okay, you see a rectangle in the middle and 2 triangles on the outside. Okay, this helps derive our formula up here, which is a combination of a triangle and a square. All right, when we are finding our trapezoid, remember again, same with the height. You'll see that they'll make straight lines with a 90-degree angle as our height. You will also see sometimes they'll do this, and they'll also make the height like that as well. Okay. All right, in this example, I have it where our top base is 7 inches, our bottom base is 13 inches, and our height is actually going to be 3 inches. All right, with our formula, we have the base 1 plus base 2 Base 1 is usually the top, base 2 is usually the bottom. Again, with the commutative property of addition, order doesn't matter. Okay? We're then going to divide that by 2, and then finally, after all of that's done, we're going to multiply by the height. Okay? So base 1 is going to be 7. We're going to add that to our other base, which is 13. Base 1, base 2. I'll even write that base 1 plus base 2. We're then going to divide that by 2. And after all that, we're going to multiply by our height, which is 3. Again, with order of operations, okay, we want to take care of our multiplication and division from left to right. If we look from left to right, we see that division is first. We're going to work on this one first. 7 plus 3 is going to be 20, divided by 2 times 3. Again, I still have that division there. I need to get rid of it. 20 divided by 2 is going to be 10. Lastly, I'm left with multiplication, 10 times 3, which is 30. And because I'm multiplying, our bases have the inches and our height has the inches, it's going to be inches squared. Area is always our units squared. All right. Again, we're going to do some examples practicing all of these. We've got 5 examples here. Should be relatively quick and snappy. All right, example number 1. We have a parallelogram here. Notice, because our sides are a little crooked, and you also notice that our height comes down and makes a 90-degree angle with our base. Okay. The formula for area of a parallelogram is going to be our base times the height. In this case, our base is 6 inches times our height, which is 8 inches. 6 times 8 is 48. And again, inches times inches is going to be inches squared. Example 2. And we've got a beautiful triangle here. In this case, we have a right triangle because they make a right triangle with 2 of the bases. All right, for a triangle, remember it's half of the base times the height. So we have half of our base, which is 3, our height, which is 3. And remember with PEMDAS, we want to do the stuff in parentheses first. We have half times 9. 3 times 3 is 9. Half of 9, thinking you got $9, well, half of $9 is $4.50. So half of 9 is going to be 4.5. And again, that's going to be feet squared because our units are always squared. All right, example 3, we have a trapezoid here. Okay, notice one base is longer than the other, and then our height's given with this 90-degree angle with one of the bases. So again, our formula is going to be wrong formula. We have base 1 plus base 2 all divided by 2. Finally, divide that all by the height. And again, it doesn't matter which one is base 1 or base 2 with that commutative property of addition, which means order does not matter. Okay? We're going to put 7 on top, 7 plus 9. We're finally going to divide that by 2. And after all that, we're going to multiply that by 3, which is our height. 7 plus 9 is going to be 16. 16 divided by 2. Carry down that multiply by 3. 16 divided by 2 is going to be 8. And then we have 8 times 3. I'm going to bring my math over this way because I've run out of room. 8 times 3 is going to be 24. And because we have inches times inches, it's inches squared. Last 2 examples. Example 4, a rectangle with a length of 6.5 feet and a width of 2.3 feet. Find the area. With geometry, the first thing you got to do is draw your shape. Okay, I have a rectangle. I know rectangles have one side that's longer than the other side. And again, pardon my pictures, I try my best. It says that my length is going to be 6.5 feet and my width is going to be 2.3 feet. Well, I know the area of a rectangle is length times the width. So I'm going to take my length as 6.5 feet times 2.3 feet. Okay. When you multiply that all out and remember to move over the decimal, you should get 14.95 feet squared. Okay. All right, our last one, example 5. A parallelogram has an area of 72 meters squared. We know the height is 8 meters. Set up an equation to find the base B, then solve for B. All right, remember, we're setting up an equation, which means we have an equal sign. Okay. Parallelogram, remember our parallelograms are just a tilted square. I know the area. To find the area of a parallelogram, my area equals the base times the height. So I'm going to plug in what I know. It says the area is 72 meters squared. So for area, I'm going to put in the 72 equals, we know the height is 8 meters, so I'm skipping the base, but I know the height's going to be 8. It says set up an equation to find the base b. Okay, I don't know what b is, so I'm going to put a variable for our unknown. So we have our equation. We just set up our equation. All we did was plug in the numbers we knew into the formula. Now we're going to solve for b. This is a one-step equation. We're going to use our inverse operations. Okay? b times 8, that's multiplication. The inverse of multiplication is division. So I want to divide both sides by the coefficient, which happens to be 8. So I'm going to divide both sides by 8. 8 divided by 8 cancels. I'm left with 72 divided by 8, which is 9, equals b. And it's not just 9b, we know our base is going to be 9 with units, meters, meters, meters. Alright, when you are putting this into your notebook, again, you fold down hamburger style, hamburger style, hamburger, hamburger. You're going to put glue on the back of your foldable, again, where it says glue, okay? And you're going to glue it into your notebook. Alright, if you have any questions, feel free to ask your teacher. We are going to do more practice on this throughout the week. Have a great day.